Hi guys, this is Miss Elkins. Sorry I'm not here today, but I want to do a little review of linear inequalities with you. You should have your paper from Miss Guarini, and you can follow along with these notes if you don't remember how to do this. Okay, so number one says, which ordered pair is a solution to the linear inequality below? There's two ways to do this. They're showing you a graph, so that means they want you to graph it. You could also substitute each one of those values in for x and y and see which ones come up with a true statement. But I feel like that's more work than just solving it and graphing it. So here we go. We're going to solve this for y, and then we're going to graph it. The first thing we're going to do is subtract 3x from both sides. So let's show that step now. So subtract 3x from both sides, and you wind up with this equation, or inequality I should say. Negative 5y, don't forget that negative sign goes with the 5, is greater than or equal to negative 3x plus 10. And then we still have to solve for y, but there's something important going to happen here. We're going to be dividing by a negative, which means that inequality symbol must flip around. So we wind up with y is less than or equal to negative divided by a negative is a positive, so that's 3/5 x. Positive divided by a negative is a negative, so that's a negative 2. So we'll graph that, starting with the y-intercept at negative 2, and then going by the slope of 3/5, which means I'm going to rise 3 and run 5. 1, 2, 3, 4, 5. And that's about as far as I can go there. And I'll go backwards, down 3, and backwards 5. 1, 2, 3, 4, 5. And that's about as far as I can go there. Because the symbol is or equal to, this is a straight line. A straight line going through here, something like that. And because it's less than or equal to, that means we will shade underneath. And we just need to tell which one of these points would actually be within that shaded area. So if you look at 1, 4, oh, that's up here. That's not it. If you look at 6, negative 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, that is within the shaded area, so that's our correct answer. You can see that negative 5, 1, 2, 3, 4, 5, negative 2 is not there, and 2, 0, also not there. So that's how you would do these first two problems. The second and third two problems, number 3 and number 4, these are the ones you are going to have to do substitution with. You can use each one of these values and plug them in for the x value and the y value and see which one gives you a true statement. So for instance, I could try A. That would mean I'll plug in 6 in place of x, and I'll plug in negative 4 in place of y and see if I get something that's less than 9. 2 times 6 is 12. Negative 3 times negative 4 is positive 12, and 12 plus 12 is not less than 9. I'm going to keep doing that with each one of these until I get a true statement. All right, I'm not going to give you the answer there. Okay, number 5, it says identify the ordered pairs that are solutions to the linear equality. You will have to do substitution with each one of those and check mark the ones that are correct. I'll give you a hint. 3 of them are correct. There are 3 correct answers on number 5. So just check mark the ones that are correct. Okay? And then on the back, you're going to graph those systems of equations or systems of inequalities and see where they overlap. Make sure you color them in correctly. Remember, if it's greater than, you shade above. If it's less than, you shade below, and the same thing is equal to. Be careful with dotted lines and solid lines, and be sure that you put a big fat S on the part that is the solution. All right, I hope you guys have a good day. I hope you get done with this in class and don't have homework. I will see you guys on Tuesday. Have a good day.